Okay, so in this video, I want to talk to you about applied forces and how that affects the uh, object when it's applied at an angle. Let's assume that we have the same box, the box M. So it could be whatever we want it to be. And let's say that it's, in one case, there's a force pushing on it at an angle theta, and then another side there's an angle pulling on it at an angle theta. That could be any angle you want. But in both of these boxes, both of these scenarios, the boxes are the same, the angles are the same. So if I want to look at this box being pushed, what I care about in a frictionless environment is that there is a component of the forces that is going to be acting on the box in a horizontal to the surface manner. The box itself has a mass of m, and the weight of the box would be pulling down, and the normal force would be pushing up. If there's no friction, the normal force really doesn't matter at this time, unless the box is getting lifted up and off the plane. We're not going to deal with that type of a scenario here. So what we want to do is figure out the acceleration. And to figure out the acceleration of this box, we are going to say that the acceleration is equal to the sum of the forces divided by the mass. So in this box, there is the forces acting on it, and the components of those forces are going to be Fx is equal to the force times the cosine of theta, and Fy is going to equal the force times the sine of theta. So what's in green is the xward force, and what is in red that I'm going to draw now is going to be the y-ward force. Again, if there's no friction, the y-ward force really doesn't even matter here. And so what we're going to say is that the acceleration of this box is going to equal the forces acting on it in the direction of motion. The box itself is going to move along this plane, back and forth. It's not moving this way. It's moving left and right. And so the forces in that direction are the green vectors there. So the sum of the forces are going to be the force in the x direction divided by the mass, which would be something like F cosine theta divided by m. The big thing that you need to recognize is that in the box on the left, you're moving to the right, and the box on the right, you're moving to the left. If you have any questions, as always, let me know.